Welcome to the Walton Pi. Today we're going to be using Newton's method to estimate the zeros of some functions, and we are going to walk through how to go about doing that using either Excel or Google spreadsheets. Alright. Alright, let's suppose that we were given the function f of x is equal to 3 sine x plus 17e to the x minus 17x cubed, and we are asked to find a 0. So we are asked to find where is this equal to 0. Well, this is something that we don't really want to compute by hand, and so what we can do is we can use Newton's method. Now, Newton's method is going to require that we know the derivative, and so when we take the derivative of this function, we will find that the derivative is 3 cosine of x plus 17e to the x minus 51x squared. And so that's what our derivative is going to be, and if we want to use Newton's method, we are going to be computing repeated values of x. And so what we are going to need to do is we are going to need to remember the formula for our different x's. And that formula is going to be, we have x, so our n plus 1 value, so n plus 1 is going to be equal to our nth, so x sub n, minus f of xn divided by f prime of xn. If this is not a format that makes sense to you, check out the last video. I go into more depth into this, and it's in a way that is easier to write. However, in Excel it's kind of difficult to write fractions and stuff in a way that makes sense visually. And so what we can do is, if we can start by making a guess. So we're going to make any guess, so let's say our guess is 6. We want to guess that, let's get the formatting the same for all of those. There we go. So let's say that our first guess for x is 6. What we can do is we can then compute what is f of x. Well, that's going to be this equation. Now, we don't have to do this by hand. Excel and Google spreadsheets, they both have the ability to have functions inside. So we're going to start by saying equals, and now it is saying, oh, this is going to be some function. So since we are adding things, we will say equals the sum of, we have 3 times sine of, now where it says x, we are going to click to the right. So that's saying sine of whatever our current x value is, close parenthesis. Then we are going to do plus 17 times, now we can't just do e raised to something. This is going to be exp. So this is Euler's number raised to a power. So this is how we would write e to the something. So exp of x is the column to the right. So there's that one. And then we have minus 17 times x cubed. So times this to the 3. And then we can close the parenthesis and click enter. And that is going to compute that. Let's change the size of this one a bit. There we go. And let's actually change all of those sizes. There we go. And then we can do the same thing for f prime. So this is going to be equal to the sum of 3 times cosine of x, oops, come back, cosine of x, let's see, plus 17 times the exponent of this, and then we have minus 51 times x squared. And there is our derivative at x. Now, at this point, what we can do is we can say, well, we now can just compute these things pretty straightforward, but the next thing is we need to know what is x sub n plus 1, so what is our next x value? And we can use this rule. It's going to be x sub n, so this is going to be equal sum of x sub n, so the x right above it, minus f of x sub n, here's that, divided by f prime of x sub n, which is that. And then we can go, boom, there we go, we got that. Now these two, if we just drag, this is now saying the sum of sine of a3, so that's this x value, plus 17 times e to the a3, so that's this thing again. And so now that we have a whole row of this, we can now just drag this down, and what's going to happen is notice how after a few times it's essentially 0. And at this point everything stays the same. Now we can do this for any function that we need to. All we would have to do is we can change our x value. So let's say we want, instead of our first guess to be 6, our guess is 9. It went to the exact same thing. Are there other zeros? Let's try some big negative number. And this time it went to something else. It went to 1.8985, whereas if we started at 6, we go to 4.54. There's different zeros, and depending on where we guess, it's going to give us something different. So if we start somewhere in between, so maybe 3, this one goes to the 1.89, but if we started at 4, this goes to the 4.54. So there's different values that we can do, and so this makes a lot of this pretty straightforward to do. And so what we can do is we can do this for other functions. So let's say that instead of this function, we were given f of x is equal to 17 cosine of e to the 5x. Let's see. Yeah, let's just do that. So then the derivative of that is going to need to use the chain rule. So f prime of x is going to be equal to, let's see, so derivative of cosine is negative sine, so that's a negative 17 sine of e to the 5x, but then multiply that by the derivative of the inside, which is 5e to the 5x. And so that's what those are going to be, and now we are just going to have to change what are these functions. So our first function, instead of being that, is going to be 17 times cosine of, and then we have e to the 5x. So there's that, and then the derivative of that is going to be, we have a negative 17 times sine of e to the 5x. Let's see, then times 5 times e to the 5x. And I think I need one more parenthesis, and we're good. And so now what we can do is we can see, does this have any zeros? And eventually we do. Let's see, is that... Oh, notice how these are different than up here. So we really needed to then take this and drag this all the way down. Let's see. So is everything right? So x is our previous x minus f of x sub n, which is this divided by f prime. So yeah, so all of these should be correct. So yeah, so all of these can get dragged down, and hopefully at some point we get something that's 0. But this one didn't work out very nicely. And so this is something that can happen. Certain guesses are going to cause problems. If we try 0, that's going to go to something else that's causing some problems. And so this sort of process is not guaranteed to finish in a nice way, but it usually should. So let's see if we can guess about where that would happen. So let's see. So cosine is equal to 0 at pi halves. So we are looking for when is e to the 5x equal to like a pi halves. Let's see. So pi halves is about 1.5. And e is about 2.8. So we probably want to try something that's like around 0.4. And see if that gives us a nice way of being able to get there. Let's see, so those are both right. And let's see. And yeah, x is not getting to any nice numbers. So this one is one that is probably not a good function for us to be even trying. But let's modify it a little bit and just stick on a minus x squared. And that means that the derivative will have a minus 2x at the end. So let's just modify those here. So let's see, minus x squared. And then this one has a minus 2x, or minus 2x. And did those make any of the numbers come out nicer? They do. Which makes me wonder if somehow in our dragging and dropping method something was broken. So let's try removing that and removing that and take this and drag that through. Nope, something was just up with that original function. So this one finishing at about negative 4.123 for these functions. And so that's how you can be able to use an Excel spreadsheet to be able to compute these sorts of things. Hopefully they'll give you ones that actually come out fairly nice. The 17 cosine e to the 5x, that one didn't work out as great as we'd hoped, but modifying it a bit gave us some nicer values. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.